Hi, compound interest is one of my favorite sections to teach. I wouldn't copy down the example there. That's just something we're going to work through. Not really noteworthy for you. But uh, it's one of my favorite sections to teach. And the reason is there's a lot of people that when they get finances, whether it be college loans or home mortgages or retirement, they don't realize how things work with interest. And they don't realize the advantage of paying off a loan quickly or investing early in retirement. And there's just lots of cool things you can do with this. A lot of people say, well, how am I going to use math? And there's a lot of fields that you could go into in life where you're not going to use the math that you use. Hopefully you're gaining some skills in math that maybe carry over, like the logical reasoning and such. But this here is something that anybody who deals with money, which is pretty much everybody, is going to be able to use throughout their life. So pay attention to this section if nothing else. This is probably the section that will benefit you the most in your life in this class. But we're looking at compound interest. There's two kinds of interest, simple interest and compound interest. Our book hits simple interest just a tiny bit, and it's in, I think, one or two of the homework questions. But for compound interest, I'm just going to pose this question first of all, and I wouldn't write this down. Let's say you have $1,000 in a savings account. It's going to earn 4% interest in a year. How much would you have after 1 year? Well, if you think of, okay, 4%, well, how do we write that as a decimal? It's going to be 0.04. So a lot of people then would say, well, if I have $1,000, I'm going to multiply that by 0.04. And when they do that, they come up with 40. Well, that's a bad bank. If you're putting your money into the bank, you give them $1,000, after a year you have $40, go somewhere else. But what it's really doing is saying that you get $40 in interest. So you really have $1,040 at the end. So your multiplier can't be 0.04 or 4%. Instead, it's 1.04, which really ends up as being, if you have 104%, that gives you 1.04. You get to keep your 100% of the money, but they give you 4% additional. So that would be the amount after 1 year, if it's 4% a year. Now for 2 years, a lot of times people say, well, it's going to be $1,080. I'm getting $40 back from the bank a year. But what's really happening is you have $1,000, and in that first year they're going to give you 4% interest, so you have $1,040. Now in that second year you're earning interest on $1,040, not $1,000. So you actually get a little bit more when you do this 1,000 times 1.04 times 1.04, or probably you just write 1,000 times 1.04 squared. Instead of 1,080, you actually end up with $1,081.60. So you get an extra $1.60 off that $40. Doesn't seem like much, but when you actually go through in some of the problems, and we'll do some of this later in class at least, if you're investing in your retirement starting when you're, say, 25, that extra amount that you get every year, you start getting interest on the interest on the interest, and it starts going up startlingly fast by the time you get close to retirement age. In addition to an increase in time making a big difference, the other thing that makes a difference is how often they compound interest. If you have a savings account, it probably gives you interest quarterly. So what happens there is instead of just having $1,000 for the whole first year, after 3 months, 1/4 of the way through the year, they give you more money. And now you're getting interest on that. And then halfway through the year, you get a little bit more interest. And then 3/4 of the way through the year, you get a little bit more interest. Or credit cards. Credit cards, they do it monthly because for them, they want to get the interest going up as fast as they can because that's money they make. So we're going to look at that too in this section. So here's where I'd start writing if I were you. The book gives two different equations, one for interest compounded annually and one for interest compounded. You can use it for monthly or quarterly or semi-annually or daily. I'm just going to give you that second one, and you can use that second equation for the ones that are annually. But A equals P, both capital, times with parentheses 1 plus R over N, and the parentheses to the N times T power. But this equation here will work for interest no matter how many times a year it's compounded. I'm going to write out what the different variables stand for. So A, I'm just going to say it's the amount of money you end with. P then is the principal, PLE, and another way to say that is that's the starting amount. One is just number one. R is going to be the interest rate, In our previous example, that was the 4%, which I'm going to throw in there that in parentheses that has to be in decimal form. Now in that example, we did the 1.04. The 1 is this 1 over here in the equation. So for R, you just would put in the 0.04 if it was 4%. If it was 4.5%, which I think my mortgage is right now, then you'd be 0.04 for the 4% with a 5, so 0.045. So don't put the 1 in there. N, that's going to be the new part. N, lowercase n, is the number of compoundings per year. Number of compoundings per year. You could write down an example if you wanted to. You could write a couple things below, but if it's monthly like a credit card, then N would be 12. They're calculating interest 12 times a year. Quarterly, like 4 quarters in a dollar, N would be 4. You're getting interest 4 times a year. Daily, 365. T then is going to be time, like usual, but it's always going to be time in years. So if you get a question that says, how much do you have after 6 months, you'd have to put in 0.5, or how much do you have after 1 month, it'd be 1/12, whatever that would be in decimal form. So that's our equation right there. And now let's go and do some examples with it. I guess one, we could look and see, well, does it work for the example we did before? If we had, I don't know if I'd write this down, I probably wouldn't, but A equals 1,000 times 1 plus, our interest rate was 4%, so 0.04, and we were looking at it as though it's compounded once per year annually. So I'm going to put a 1 in for n. And the n in the fraction and the n in the exponent will always be the same, so we'd have a 1 up here times 2. And if you take that and punch into your calculator, you can do it exactly how it's written. Just do 1,000. You could do multiplication if you wanted to, or just parentheses 1 plus 0.04 divided by 1 and your parentheses. Oh, you do need to put your parentheses up here. I used to put parentheses there in the equation, so I'm in the habit of saying exactly how it's written. But you need to force it to do the multiplication in the exponent. Otherwise, it'll just do this to the first power and then take that answer divided by 2. So add parentheses in there. You may want to put parentheses in the equation as well to help you remember till you get used to it. But if you punch that in, you'll get the $1,081.60. If you wanted to go through and see what's that going to be if we were doing this quarterly, like a normal savings account, the only difference you would have would be, still be the plus 1.04, or 1 plus 0.04, but now we'd have to divide by a 4, because you're getting interest 4 times a year, and then 4 times 2. And you come up with, instead of $1,081.60, you'd have $1,082.86, so an extra $1.26. Doesn't seem like much, but over time it adds up, especially if you have a higher return than the 4%. Alright, so I figure I'll give you this example and then we'll pretty much be done. I'll probably show you how to type it in a calculator, but if you're getting the right numbers when you punch it in, you can skip that very last part of the notes. But let's say you're looking at buying an $80 pair of jeans. You decide to invest the money in your retirement instead. If your return is 11% monthly, how much will it grow to when you retire in 50 years? Couple comments. One, some years if you invest in mutual funds in the stock market, you're going to lose money, and that's painful. But the average return, 12%, is a pretty realistic amount to get. I changed this to 11% monthly just because I want to put the numbers into the equation and not have it be annual interest. You also can get more. I have some of my money in aggressive growth fund that last year got 18% return. So it can be good. And this is hopefully going to show you that investing in your retirement when you're young is smart. I started when I was 20. Yeah, it's a good idea to look at Roth IRAs. Anywho, let's go with this thing. So first thing, like I've been trying to convince you of all year long, start by writing out the equation. You're less likely to make mistakes, and you'll have the thing memorized by test time because, yep, I'm going to ask you to know it from memory on the test, guaranteed. So, all right, so we have our equation there, A equals P, parentheses, 1 plus R over N, parentheses, to the NT power. And I added the parentheses in there even though you don't need them. When you type them in, you'll need it when you punch it in. So $80 pair of jeans. Something you might want to do before the number actually comes up is come up with what do you think a reasonable amount that this would grow to would be. Figure if you're 16, you're going to retire when you're maybe 66. That's why I came up with the 50 years. But is it $200? Is it $1,000? You know, how much do you think that actually would grow to? So I have 80 as my principal. That's our starting amount. We have 11%. So to change the percent to a decimal, we always move the decimal point 2 places. So that's a 0.11. Monthly, so how many months in a year? So that's going to be my 12. And now my parentheses and my exponent then, it's going to be 12 for n, and now 50 for years. If you wanted to, you could just do that in your head, just put it all to the 60th power. That'd save you some time. If you punch this thing in to your calculator, you're going to end up with $19,090.98. Really makes you stop and think. Do you have the money now? Do you start investing now in your retirement? Problem is there's always something to pay for. If you're are you saving for college? Are you paying off college? Are you paying off your house? So it's always kind of tricky with what to do. But most people say it's a good idea to try to max out a Roth IRA every year once you start making money, at least once you're out of college. So I'll show you how to punch that in a calculator, and then we're done. And I'll do that last example, the $80 pair of jeans. And then I skip the multiplication, just my parentheses, 1 plus 0.11 divided by 12, and the parentheses. Now you have to do your exponent key. So some operating systems will jump up like this, other ones will have the caret, the little up arrow, but you need to have parentheses in there. So if it's monthly, you have to do 12 times then your number of years. One final comment, as you go through and do these, just a reminder, if you have a question that's asking you to do that, well, what about if it's quarterly? What if it's annually? You can just do second enter if you want to, and bring up the equation from before, and then just go back and change the parts that you need to change. That's it. Hope you enjoy the section.